So let's investigate the chromodynamic or strong force that holds the proton and neutron in the nucleus. And we're going to investigate that in terms of the composition of the proton and neutron, the quarks composition of those, in terms of the Rishon elements of this model. And so for the proton, we have a U quark, two U quarks, and a D quark. And for the neutron, we have two D quarks and a U quark. And if we look, we'll see that the U quark is composed with what we might call what we do call a T prime Rishon, and a generic combination of a V and T, a generic V and T, and then a T prime. So we have a generic V and T, and then we have a T prime. Whereas the D quark, we have a generic V and T, and then we have an anti-V prime. And we have the opposite composition, of course, over here, because we have the D quarks with a generic V and T, and then an anti-V prime, likewise for the other D quark, and then a generic V and T and a T prime. Now, the chromodynamic force is impulsed by the color charge. And you may notice that these Rishon elements have semicircles and cones. And in the generic V's and T's, the color on the right side of the semicircles tells you the color of the Rishon element. So in this case, we have a green. In this case, we have a red. And we can see that the actual quantum that designates these color charges displays. And in the case of the green, we have a -5, a 0, and a 5. In the case of the red, we have the opposite, a 5, a 0, and -5. If we go down here, we have purple and its opposite, yellow. And the purple is 5, a 0.5, a -0.5, and a 0. I misspoke earlier. These are 0.1/2, minus and positive 1/2, and 0. And so here we have 1/2, -1/2, and 0. And here we have the opposite, -1/2, 1/2, and 0. And here for the orange and blue, we have 0, 1/2, and -1/2. And then for the blue, we have the opposite, 0, -1/2, and a 1/2. And then for the prime Rishon elements, we have a cone designating the color. And so for this prime T Rishon is blue, yellow, and then red. And similarly, the Rishons are configuring the quarks for the neutron. And so we will see that the color that is given to a quark, since the generic V and T cancel, will be given to it by its prime component. So this is a blue U quark, this is a yellow U quark, and this is a red D quark. And here we have a yellow D quark, a blue D quark, and a red U quark. And so that each of the nucleons must consist of 3 colors summing to white. Now, I have used a different convention than is usually technically used in the physics, where they would use blue, red, and green as the 3 colors, primary colors, and green would be an anti-color. But here I am using yellow instead of green and having its anti-color as purple. And then I'm using green as the anti-color of red. And so in the next videos we would demonstrate how the exchange of gluons in terms of these Rishon elements is consistent with the standard model.